Hey, how's it going, everybody? Welcome back. We're in our spring semester, so take a look at Chapter 11, Sample Surveys. Some background. We have learned ways to display, describe, and summarize data, but have been limited to examining the particular batch of data we have. To make decisions, we need to go beyond the data at hand into the world at large. Let's investigate three major ideas that will allow us to make this stretch. So idea one, examine a part of the world. The first idea is to draw a sample. We like to know about an entire population of individuals, but examining all of them is usually impractical, if not impossible. So big keyword there, population. Population means everybody of what you're trying to study, okay? So for example, if you're talking about Major League Baseball players, the population would be every single Major League Baseball player. Okay, so that brings us to our next big keyword, sample. So we settle for examining a smaller group of individuals, a sample selected from the population. So for example, if you wanted to talk about Major League Baseball players, okay, that's the population, the sample would be maybe like you'd pick like 40 or 50 of them to study across all of Major League Baseball players. So the sample would just be the small group, and the population would be everybody, okay? So sampling is a natural thing to do. Think about sampling something you are cooking. You taste, examine a small part of what you're cooking to get an idea about the dish as a whole. So for example, if you're cooking like soup or you're making like a spaghetti, okay, with sauce, you just try a little bit to make sure it tastes okay. You don't need all of the the spaghetti sauce or all of the soup to figure out how it tastes. You just need a little small sample, and that tells you generally about what the rest of it is. So the same thing happens when you're doing sampling, when you're trying to find part to the whole. So continued here, opinion polls are examples of sample surveys designed to ask questions of a small group of people in the hope of learning something about the entire population. Okay, sample survey is designed to ask questions of a small group of people in the hope of learning something about the entire population. Professional pollsters work quite hard to ensure that the sample they take is representative of the population. If not, the sample can give misleading information about the population. So once again, these are professionals that you've probably heard a lot of things recently with the election, how they do these polls to figure out who people are voting for or what issues that are concerned, that are their big concern, the things that they want to, the laws they want to see passed, et cetera, et cetera. So by doing like a poll, if they do it right, okay, they can get good information about what the entire population, like how they feel, like how does the entire population feel, or what like the percentages. And they don't ask everybody; they just do a sample. Okay, so that's sample surveys. All right. So bias. So here's yeah. All right. So sampling methods that, by their nature, tend to be over or under emphasize some characteristics of the population are said to be biased. Bias is the bane of sampling, the one thing above all to avoid. There is usually no way to fix a biased sample and no way to salvage useful information from it. The best way to avoid bias is to select individuals for the sample at random. Okay, the value of deliberately introducing randomness is one of the great insights of statistics. So remember, you are deliberately using randomness. Okay, you're not just willy-nilly getting whatever. No, you have to think about how you want to make it random. But here's the big idea too. Randomize. Randomization can protect you against factors that you know are in the data. It can also help protect against factors you are not even aware of. Randomizing protects us from the influences of all the features of our population, even ones that we may not have thought about. Randomizing makes sure that on the average, the sample looks like the rest of the population. Not only does randomizing protect us from bias, it actually makes it possible for us to draw inferences about the population when we see only a sample. Such inferences are among the most powerful things we can do with statistics. But remember, it's all made possible because we deliberately choose things randomly. How large a random sample, it's the sample size is the big idea for number 3. Okay, so big idea number 3 is it's the sample size. How large a random sample do we need for the sample to be reasonably representative of the population? It's a great question, right? How big of a sample do you actually need? It's the size of the sample, not the size of the population, that makes a difference in sampling. Exception: if the population is small enough and the sample is more than 10% of the whole population, the population size can matter. So one more time. If the population is small, okay, and the sample is more than 10% of the whole population, the population size can matter. Okay, so you're going to see this pop up a lot about when you select a sample, you generally want to keep it under that 10% of the total population. So the fraction of the population that you're sampled doesn't matter. It's the sample size itself that's important. So it doesn't really matter how much of the population that you're sampling. It's generally just the sample size itself. So you're not trying to aim for 2%, 5%, 8%, 6%, whatever. It's generally the size of the sample that is most important. Okay, how many you get to participate. Does a census make sense? So why bother determining the right sample size? Wouldn't it be better to just include everyone and sample the entire population, right? Wouldn't that be nice to ask everybody about what you're concerned about, what their thoughts are on a certain subject or whatever it is? That would be great, okay? That special type of sample is called a census. In fact, we just had one. You probably heard a lot of emails and stuff go out from the superintendent about filling out the census, okay? So in America, United States, every 10 years, we do a census where we send stuff to everybody's mailbox, or they can do it online now, and they can fill out about their household. It just takes a few minutes, but it's a way for the country to figure out kind of what the entire United States looks like. Okay, it takes a lot of effort, costs a lot of money, so we only do it once every 10 years. There are problems, though, with taking a census. It can be difficult to complete a census. There always seem to be some individuals who are hard or expensive to locate or hard to measure, or it may be impractical. Okay, for example, food. Okay, it's not really impractical to sample all the food because, you don't want to eat all your food or waste all your food. Populations rarely stand still. Even if you could take a census, the population changes while you work. So it's never possible to get a perfect measure. So for example, if you give everyone a month or two to talk about the family size, right, how many people live in the household, there may be people that move out. There may be new babies that are born. There may be people that pass away. Okay, so it's never going to be perfect. So you have to kind of like take it as you get it. Taking a census may be more complex than actually just doing a sample. So populations and parameters. Models use mathematics to represent reality. Parameters are the key numbers in those models. A parameter that is part of a model for a population is called a population parameter. We use data to estimate the population parameters. Any summary found from the data is a statistic. The statistics that estimate population parameters are called sample statistics. So one more time, okay? Models use mathematics to represent reality, and parameters are the key numbers in those models. Okay, a parameter that is part of a model for a population is called a population parameter, and we use the data to estimate population parameters. Any summary found from the data is a statistic, but the statistics that estimate population parameters are called sample statistics. So here's the notation that we're going to use. We typically use Greek letters to denote parameters and Latin letters to denote statistics. So the big important ones here, right, are mean, standard deviation, correlation, regression coefficient, and the proportion. So for the mean, we use either X bar, or the book, this PowerPoint likes to use Y bar, so you'll kind of see both. But that's just the average of something, okay? And the parameter we use is mu, okay? Pronounced mu, not moo, okay? Mu, okay? Mu. That's that little thing we've talked about before, okay? The statistic standard deviation S, the parameter is sigma, okay? That's that O with a little line on top. There's the correlation coefficient R, which the parameter is rho. That looks kind of like a P. The regression coefficient, that's that B, we call beta, all right, pronounced beta. And then last but not least, the proportion, okay, that is little p hat, all right, and that's pronounced P. All right. So let's talk about the simple random samples. We draw samples because we can't work with the entire population. We need to be sure that the statistics we compute from the sample reflect the corresponding parameters accurately. A sample that does this is said to be representative. So, we draw samples because we can't work with the entire population, right? So when that sample actually reflects the population accurately, okay, that sample is considered representative. So, continued, we will insist that every possible sample of the size we plan to draw has an equal chance to be selected. Such samples also guarantee that each individual has an equal chance of being selected. With this method, each combination of people has an equal chance of being selected as well. A sample drawn in this way is called a simple random sample. You'll see this usually commonly referred to as SRS. So one more time, an SRS, a simple random sample, would be like in a classroom. You might have seen this before, where a teacher has those little popsicle sticks, right? Those little wooden sticks with people's names on it. And they'll take it, they'll pull it and say, oh, this person, it's your turn to answer the question, or something like that. Okay, it's like a lottery. Okay, simple random sample is exactly what it sounds like, where everybody or everything has an equal chance of being selected. Okay, and SRS is the standard against which we measure other sampling methods, and the sampling method on which the theory of working with sample data is based. So, this SRS, simple random sample, which sounds pretty easy to understand, they say it's just the standard. It's like, this is kind of what you should consider before doing like anything else. Okay? All right. So to select a sample at random, we first need to define where the sample will come from. The sampling frame is a list of individuals from which the sample is drawn. Okay, sampling frame is a list of individuals from which a sample is drawn. Once we have our sampling frame, the easiest way to choose an SRS is to assign a random number to each individual in the sampling frame. So, for example, in a classroom, I could give everybody a number from the roster, like you're number 1, you're number 2, you're number 3. Everyone gets a number, and then I do something to select the random number, and everyone's got an equal chance. Okay, sampling frame is everybody you're trying to, get your sample from. So samples drawn at random generally differ from one another. Each draw of random numbers selects different people for our sample. These differences lead to different values for the variables we measure. We call these sample-to-sample differences sampling variability. So, once again, everyone you do in the sample is probably going to be a little bit different, and that's okay. Excuse me. But the difference from from person to person, right? From sample to sample, those little differences are called the sampling variability. Okay, it varies. And so simple random samples. Okay, SRS was the first main one. Here's the next one. You're going to see this one a lot too. It's called stratified sampling. Simple random sampling is not the only fair way to sample. More complicated designs may save time or money or help avoid sampling problems. All statistical sampling designs have in common the idea that chance, rather than human choice, is used to select the sample. Okay, so once again, the idea is that it's all random, it's all by chance, that you're not actually selecting people or selecting things, but the general idea is everybody's selected at random, or everything is selected at random, okay, by just chance. Okay, that's kind of what the big design picture here is. Okay, so designs used to sample from large populations are often more complicated than just simple random samples. Okay, it's not always as easy as just picking names out of a hat, right? So sometimes you need something different because things get complex. So sometimes the population is first sliced into homogeneous groups called strata before the sample is selected. Okay, so when you have your strata, that's like boys or girls, okay, or maybe like teenagers and adults, or maybe you'll see different groups like football players or basketball players. Okay, maybe people that have their license or don't have their license. They're just smaller groups that you work with. Then simple random sampling is used within each stratum before the results are combined. This common sampling design is called stratified random sampling. So stratified, strata, okay, stratum is a group of stratas, okay, and it's stratified random sampling. So you put people in groups, and then within the group you do SRS. So maybe in each group you do 10 people or 15 or 30 people in each smaller group, and then you put all those groups together. The most important benefit of stratifying can reduce the variability of our results. When we restrict by strata, additional samples are more like one another. So, statistics calculated for the sampled values will vary less from one sample to another. Okay, so in the groups, generally speaking, there's less variability, okay, versus the entire population if you were to do a simple random sample of entire population. So, stratified random sampling can reduce bias. Stratified sampling can also help us notice important differences among groups. So once again, by doing the stratified random sampling, it's a good way to reduce bias. So you might see a question come up that asks you, okay, here's a sample, or here's a method for finding a sample, and it's just a simple random sample. How can you make it better to reduce a bias? We'll say, well, put them into groups, okay? Make a stratified random sample. That would reduce the bias. Also, you have each group might have their own little patterns that kind of come out. So by doing the groups, it's easier to compare and see how the groups are the same or how they're different. So cluster and multi-stage sampling. Sometimes stratifying isn't practical and simple random sampling is just too difficult. Splitting the population into similar parts or clusters can make sampling more practical. Then we could select one or few clusters at random and perform a census within each of them. This sampling design is called cluster sampling. If each cluster fairly represents the full population, cluster sampling will give us an unbiased sample. Okay, so this would be once again, let's just talk and see if it kind of explains it here better. So cluster sampling is not the same as stratified sampling. We stratify to ensure that our sample represents different groups in the population and sample randomly within each stratum. Strata are internally homogeneous but differ from one another. Clusters are more or less alike, are internally heterogeneous and each resembling the overall population. We select clusters to make sampling more practical or affordable. Sometimes we use a variety of sampling methods together. Sampling schemes that combine several methods are called multi-stage samples. Most surveys conducted by professional polling organizations use some combination of stratified and cluster sampling as well as simple random sampling. Okay, so one of the big differences between the stratified and the cluster, okay, cluster is you take a small group and you actually do the entire small group. Okay, so you perform a census within each of the small clusters. Okay, so for example, maybe you take like seniors, juniors, sophomores, and freshmen, and a stratified sample would be, okay, maybe you take each group and then you put them into small, you just like a random freshman, like a couple random freshmen, couple random sophomores, couple random juniors, couple random seniors. That would be stratified, okay? If you wanted to do this cluster idea, that would be, well, usually in like your English classes, you'll have like 9, 10, 11, 12. You'll have like 4 different like levels of English classes. So it would be like taking like one English class or 2 English classes from each grade level and like just sampling everyone in that class. Okay, that way, like maybe you pick the cluster randomly, but you just sample everybody in that group. Okay, they say that's a great way to find things that are not biased. Okay, and it's a great way to do it so that it's just generally cheaper and easier to do. Okay. Next is systematic samples. Sometimes we draw a sample by selecting individuals systematically. For example, you might survey every 10th person on an alphabetical list of students. Okay, so systematic, you've got a system. So you're going down a list and every 10 people, or maybe you're sitting there and you're just counting, okay, 1, 2, 3, 4, 5. You, hey, you, come here. I'll ask you some questions. Okay, 1, 2, 3, 4, 5. You, hey, you, come here. Let's do some more. Let's ask you some questions. To make it random, you must still start the systematic selection from a randomly selected individual. When there is no reason to believe that the order of the list could be associated in any way with the response sought, systematic sampling can give a representative sample. I think I've seen stuff like this at like Disneyland or theme parks. You might see a group of people standing around with like a little, like a piece of paper or like a what do you call that? Like an iPad or something, like a tablet, and they're going around to like random people and they're asking them questions about, oh, like what zip code are you from? Oh, like, and they might ask them other questions about their stay, are you staying in the hotel here or something? And from my understanding, when I see those things at theme parks, is usually they're doing like a systematic approach, like they're counting people. Like as soon as they get to like 100 person, like the 100th person, they'll ask that person and then they count 100 more people or something like that. I really don't know the exact system, but that's from my understanding. They have some sort of systematic approach to picking people. Or maybe they wait a certain amount of time and the first person that's closest to them or something after like 2 minutes, something like that maybe. So systematic sampling can be much less expensive than true random sampling. When you use a systematic sample, you need to justify the assumption that the systematic method is not associated with any of the measured variables. Okay, so you got to make sure when you're doing the systematic approach that there's no other weird variables going on. Okay, think about like the time of the day or other things that are happening that might throw the systematic approach off. So first we got to define the who. The who of a survey can refer to different groups, and the resulting ambiguity can tell you a lot about the success of a study. To start, think about the population of interest. Often you'll find that this is not really a well-defined group. Even if the population is clear, it may not be a practical group to study. Second, you must specify the sampling frame. Usually a sampling frame is not the group you really want to know about. The sampling frame limits what your survey can find out. Then there's your target sample. These are the individuals for whom you intend to measure responses. You're not likely to get responses from all of them. Non-response is a problem in many surveys. So if you send out like 100 surveys, are you going to get all those surveys back? Maybe half of them back, maybe 10%, a quarter of them. Like, you got to think about when you're doing your sample, how many responses are you actually going to get? Finally, there is your sample, the actual respondents. These are the individuals about whom you do get data and can draw conclusions. Unfortunately, they might not be representative of the sample, the sampling frame, or the population. At each step, the group we can study may be constrained further. The who keeps changing, and each constraint can introduce biases. A careful study should address the question of how well each group matches the population of interest. One of the main benefits of simple random sampling is that it never loses its sense of who's who. The who in an SRS is the population of interest from which we've drawn a representative sample. That's not always true for other kinds of samples. Okay. It isn't sufficient to just draw a sample and start asking questions. A valid survey yields the information we are seeking about the population we are interested in. Before you set out to survey, ask yourself, what do I want to know? Am I asking the right respondents? Am I asking the right questions? What would I do with the answers if I had them? Would they address the things I want to know? Okay, so very important questions before you start. So the more prep you do, the better your sample will be. These questions may sound obvious, but there are a number of pitfalls to avoid. Know what you want to know. Understand what you hope to learn and from whom you hope to learn it. Okay, so get an idea of what your answers might look like, okay, before you start. Use the right frame. Be sure you have a suitable sampling frame. Okay, make sure you're getting the right group to study. Tune your instrument. So the survey instrument itself can be the source of errors. Too long yields less responses. So for example, as that says, think about if you send a survey for people to answer, and let's say there's like 1,000 questions. Who's going to answer that? 100 questions. Who's going to answer that? 60 questions. Is that too many? 40 questions? Is that too many? 20 questions? Is that too many? 5 questions, 4 questions, 1 question. Okay, think about how long your survey or your study is going to last, because sometimes if it's too short, you might not get enough data. Or if it's too long, you might get people not fill it out or might be incomplete, okay? Or people might get tired and the answers might not be as correctly answered near the end of your survey, okay, or your research. Ask specific rather than general questions. So be more specific in your sample or in your surveying. Ask for quantitative results when possible. So ask for things that can be quantitative, okay? For quantities, like how many years have you done this? How many times a day does this happen? How long does it take for this? Okay? Be careful in phrasing questions. A respondent may not understand the question or may understand the question differently than the way the researcher intended it. So be very careful how you ask the questions. Okay, try to be very clear. Maybe ask a few people beforehand before you actually submit your survey to actually go out for sampling and see if you get the answers you're looking for. Even subtle differences in phrasing can make a difference. Okay, the valid survey continued. Be careful in phrasing answers. It's often a better idea to offer choices rather than inviting a free response. So, as it says here, when you have your answers, it's often better to use like multiple choice or select these, out of all these boxes, which ones do you know? So think about like those YouTube questions. When you do the surveys on YouTube, on the ads before the video plays, like which one of these commercials, from these companies have you seen ads for recently? And they give you options. Okay. They don't really give you a chance to type in a free response. It's always just give you options to select. That is generally considered a better idea to have the multiple choice options than just having a free response to write in. The best way to protect a survey from unanticipated measurement errors is to perform a pilot survey. Like I was mentioning before, maybe ask a few people before you do your full survey. A pilot is a trial run of a survey you eventually plan to give to a larger group. So maybe a pilot is something you just do with random numbers or just a small group of people that you know and you're familiar with. Okay, have them try it out first. Okay, so lots can go wrong and how to sample badly. Okay, sample badly with volunteers. In a voluntary response sample, a large group of individuals is invited to respond, and all who do respond are counted. Voluntary response samples are almost always biased, and so conclusions drawn from them are almost always wrong. So, voluntary response samples are often biased towards those with strong opinions or those who are strongly motivated. Since the sample is not representative, the resulting voluntary response bias invalidates the survey. So think about stuff like Yelp. You guys ever go on those Yelp like websites or on a website that's got like the Yelp reviews, and it says, "Hey, this restaurant." What you'll see. Instead of 5 stars, you'll see a lot of ones and a lot of fives. If someone's got a bad time, they're gonna have their voice heard. If they had a great time or their friends or whatever, they get a discount. They have like 5 out of 5 stars. Then they're gonna get like all 5 stars. So what you get is this bad responses, a bias in the response because people are volunteering their response. And generally speaking, when they volunteer their response, it's either extremely good or extremely bad. And you don't ever get a true indicator of what is actually happening. So sample badly, but conveniently. In convenient sampling, we simply include the individuals who are convenient. Unfortunately, this group may not be representative of the population. Convenience sampling is not only a problem for students or other beginning samplers. In fact, it is a widespread problem in the business world. The easiest people for a company to sample are its own customers. So here's a good example of convenient sampling. Going out to like a lunch area during school, let's say if I asked you guys, if we were in our classrooms, and I asked you guys to go do a sample. Let's say you go to the lunch area and you just find 10 people that are all close together and you survey them. That would be a convenience sampling and that would be terrible, okay? Because usually you don't get a whole lot of information about entire population from a small group that's just convenient for you to reach out to. So similarly, it says here with the business world, if you are asking your customers how they like your products, well, you might not gain new customers because you're only learning more information about your customers. So it's almost better to reach out to other potential customers to find out maybe their wants and needs as well. So here's what else can go wrong. Okay, sample from a bad sampling frame. An SRS from an incomplete sampling frame introduces bias because the individuals included may differ from the ones not in the frame. So let's say you're talking about maybe you're asking some people from the school and you're doing the best you can to find, sampling for, let's say, teenagers across California or across the United States, but you're only sampling teenagers in this area. Okay. that's a bad sampling frame. So if you're going to do stuff that's random, and which a simple random survey is great, okay, but a simple random sample, right, or a simple random survey, your frame needs to, portray the population that you're trying to understand. So undercoverage. Many of these bad survey designs suffer from undercoverage, in which some portion of the population is not sampled at all or has a smaller representation of the sample than it has in the population. Undercoverage can arise for a number of reasons, but it's always a potential source of bias. So watch out for non-respondents. A common and serious potential source of bias for most surveys is non-response bias. No survey succeeds in getting responses from everyone. The problem is that those who don't respond may differ from those who do, and they may differ on just the variables we care about. So if you're sending out, surveys through the mail, or you're making phone calls or emails, not everyone might respond. And the people that don't respond, you might want to learn the information from them, because they're going to balance out, they're going to help you discover patterns or things that you're trying to find out about that population. And so if that part of the sample doesn't get back to you, then you might not have the best statistics to work with. So don't bore respondents with surveys that go on and on and on and on. Surveys that are too long are more likely to be refused, reducing the response rate and biasing all the results. So work hard to avoid influencing responses. Response bias refers to anything in the survey design that influences the responses. For example, the wording of a question influences the responses. So think like, let's say you want to find out about how students at the high school think about, let's say, school lunch. Let's say like the breakfast, for example. And so if you ask something like, how bad do you think school lunch is? You might get people to think, oh, they're asking about how bad school lunch is. They're going to say things that are bad about school lunch and do something like that. But if you say stuff like, give your, on a scale of 1 to 10, how satisfied are you with the school lunch, or, things like that. You're trying to be as neutral as possible. You don't want to use these buzzwords or these adjectives that give a sense of feeling one way or another. You want them to be like as neutral and as gray and meh as possible, because you don't really want to have the respondent think of something like negatively or positively before they answer. You want them to be as neutral as possible. You don't want to have any influence on the respondent. So how to think about biases. Look for biases in any survey you encounter before you collect the data. There's no way to recover from a biased sample of a survey that asks biased questions. So sometimes when you see the first question, that might create this bias for the rest of the survey. So make sure you double check, triple check before you give out any surveys or anything you have to do. Spend your time and resources reducing biases. If you possibly can, pilot test your survey. Always report your sampling methods in detail. Okay. So, what have we learned? A representative sample can offer us important insights about population. It's the size of the same, not its fraction of the larger population, that determines the precision of the statistics it yields. I believe I'm supposed to say sample. It's the size of the sample that determines the precision of the statistics it yields. There are several ways to draw samples, all based on the power of randomness to make them representative of the population of interest. So simple random sample, stratified sample, cluster sample, systematic sample, and multi-stage sampling. Bias can destroy our ability to gain insights from our sample. Non-response bias can arise when sampled individuals will not or cannot respond. Response bias arises when respondents' answers might be affected by external influences, such as question wording or interviewer behavior. Bias can also arise from poor sampling methods. Voluntary response samples are almost always biased and should be avoided and distrusted. Convenient samples are likely to be flawed for similar reasons. Even with a response design, sample frames may not be representative. Undercoverage occurs when individuals from a group of the population are selected less often than they should be. So finally, we must look for biases in any survey we find and be sure to report our methods whenever we perform a survey so that others can evaluate the fairness and accuracy of our results. So That was just kind of going over the PowerPoint. Hopefully this is beneficial to you guys. And if you have questions, please email me or talk to me in class or come find me or talk to me during tutoring hours. Have a great day.